In this video, we're going to talk about our project step 5 and how to wrap this project up for our class. If you remember, our project was all about coming up with a fatigue life calculator for variable amplitude loading. And at the beginning, I gave you some histories, kind of showed an overview of the project. I gave you some time histories, asked you to pick the peaks and get rid of anything in between peaks and valleys. Asked you to find some material properties, ask you to do a Newton-Raphson solver, implement the full case 1 through 3. That's the big step. That's the rain flow cycle counting algorithm. Implementing Miner's rule for damage accumulation, and at the very baseline to do strain life fatigue calculations for identified hysteresis loops. So let's talk about that just a little bit, then we'll talk about project step 5. So I have videos on rain flow cycle counting, but the idea is if we have our hysteresis plot, remember we started off our time history with our biggest cycle. We may have a bunch of small cycles and all kinds of things going on, but let's say we just have identified 2 closed hysteresis loops. Each of these has a certain strain range and amplitude if we divide it by 2. So maybe this is loop 1 and this is loop 2. And so we can use our strain life equation with our strain amplitude for each of these, and we come up with the number of reversals for loop 1 and the number of reversals for loop 2. Then we can divide that by 2, okay, so now we have the number of cycles for strain range 1 or strain amplitude, and the number of cycles for strain range 2. Based on this, with Miner's rule, we know that we can calculate the damage for loop 1, and we can calculate the damage for loop 2 by the reciprocals of the cycles to failure, and then we can accumulate damage. Let's write it this way: D total is equal to the summation of each of these individual i's. In this case, there's 2 loops, so we would add those 2 damages together. You may have 1,000 loops, in which case you accumulate damage appropriately, come up with the total damage, and then you can come up with a life in blocks or repeats of that time history. It would be 1 over the total damage per block. And as a minimum, this is what I would like for you to do for your fatigue calculator project, but I want you to also take into account some additional feature. So that's where this project step 5 comes in. Implement additional features to software as discussed in class. Okay, so this is the class where we're going to discuss some of those things that you might do, and you're not to be restricted to these things, and it doesn't have to be all of these things. I want you to add something of interest to you that would be meaningful to you, and I expect everybody in class will have something a little bit different. Alright, so what sort of things can you do? Now, at the very base, we don't need to calculate stresses. It would be nice if you calculated stresses, so that would be something that you could do. But it's tricky, and I know it's kind of tricky. When you have a time history of strains, okay, you're going to have to use all your rules for material memory and the Ramberg-Osgood equation and the massing hypothesis in order to figure out where the stress level is. Let me undo that my pen kind of had a mind of its own. You implement the branch equations, rules for material memory. So that can be kind of difficult, and we've talked about how to do this in class. Rainflow cycle counting does not depend on counting anything other than the primary variable, in our case, which is the strain right here. So all of this can be done on strain values. But it would be nice if you calculated stress. And if you did that, some things you could do is you could actually plot the hysteresis loops. And I've made a program that can do this. You can use mean stress, sensitive damage parameters, and we've talked about several of these that can be used with the strain life approach. Okay, so that's just a modification. You can do Smith-Watson-Topper, or you can do other things. All right, so that's something that you can do. Maybe another idea is sometimes we want to do a scale factor on whatever stress history or strain history that we might have. So we talked about our pothole history, and after it's rearranged, maybe it looks something like this. Okay, and so this base time history would be with a factor of 1. But what you might do is you might multiply the entire strain history by another factor, maybe 1.5 or 2 or 3, and so you can increase the strains substantially, whatever that time history looks like. And then you can calculate the fatigue life, so you can see what changing the load factor does to the fatigue life. And this is kind of severe when it's on strain, but it can be probably more useful when it's on stress. You can take this strain history and convert it to stress. Use your modulus of elasticity for some materials, steel, aluminum, whatever. You can assume that all of those strains are elastic. They may not be, but if you make that assumption, then you can convert it to a stress history, and then you can do some other things. We talked about rainflow matrices. Okay, so you can construct rainflow matrices for these time histories. And so in the end, what I want is from you is to have a program that you've written that can calculate fatigue life for a variable amplitude strain history, but in addition to that, goes a little bit deeper into some aspect of fatigue analysis and calculation. So here are some ideas, not to be restricted to these ideas, but these are some things that you can do. With that, then I think you'll have a useful piece of software and something that you can use hopefully later on in your career if you do any fatigue analysis, but at the very least, this will give you the insight into what's going on into fatigue analysis software, commercial software that you might use. All these different commercial software packages out there now that do fatigue analysis are all based on these basic ideas.